Number 1, classify each function as a linear function, an absolute value function, a quadratic function, another polynomial function, or a rational function, and determine the domain of the function. A linear function is a function that should be of the form y equals mx plus b. Of course, instead of y, we're writing f of x, so f of x equals mx plus b. An absolute value function is a function in which we have absolute values involved. A quadratic function is a function in which we have a polynomial where the highest exponent is 2. When they say another polynomial function, they're talking about polynomials with exponents higher than 2. And a rational function is a function involving a fraction. So if we look at part A, we have a function involving fraction. So this is a rational function, and the function is defined for all x values that do not result in 0 in the denominator. But as you can see, if you plug in x equals 3, you're going to get 2 over 3 minus 3, which is 2 over 0. So our domain is going to be the set of all x's such that x does not equal 3. Part B, g of x equals x squared minus 9. This is a quadratic function because it's a polynomial and the highest exponent is 2. Now with quadratic functions, the domain is always going to be the set of real numbers. We can plug in any x we want and square it and then subtract 9. There are no restrictions whatsoever. We never get a 0 in a denominator here, so it's okay to plug in any x we want. In part C, we have an absolute value function. Its domain, again, is going to be the set of all real numbers because I can take any number I want, subtract it from 7, and then take its absolute value. There's no real number x that I could plug in here that would result in an undefined value. Part D looks like y equals mx plus b, except for we have this L of x equals mx plus b. So we have a linear function, and the domain with any non-vertical line is the set of real numbers again. With part E, we have a polynomial with the highest exponent being 5, so this is not quadratic, this is a polynomial function. Its domain, again, is going to be the set of all real numbers. Now, you may be looking at this and thinking, well, any function other than a rational function has a domain of all real numbers. And for the time being, that's right. However, we're going to encounter other functions later in this class that are not rational functions and have restrictions on the domain. But we'll talk about those later. But for this section, as you're doing parts F, G, H, I, and J, the domains in each case will be all real numbers except for where you have a rational function. So go ahead and do those problems now.